Okay, and welcome to Unit 4 on conservation of energy. This is the beginning of lesson number 2 on kinetic energy. Now, kinetic energy, it's going to be a pretty straightforward topic for everyone, I hope. And the basis of kinetic energy is we're saying that is energy having to do with motion. So our formula here is energy kinetic is equal to 1/2 times an object's mass times the square of its velocity. And this is going to give us units in joules. Okay, really is quite as simple as that. We can jump, I think, straight into this first example problem. So, example 1a, it says that we have an object traveling at 45 kilometers per hour. And the object, it tells us right away, has an energy, so say this is its velocity, an energy kinetic value of 120 kilojoules. Okay, that's going to be 120,000 joules. All right, the question is now saying, let's determine this object's mass. So if we have this formula, EK is equal to 1/2 mass times velocity squared, and we have its velocity and we have its energy, we can just rearrange and solve for mass. All right, so our mass, if we rearrange this, can be dividing by v squared, multiplying by 2. So mass should work out to 2 times the EK divided by v squared. Now we need to do a little bit of changing around here because, clearly we need velocity in meters per second and energy in joules. Well, the big one that we need to convert here is our velocity. So let's divide this value by, our cheater way 3.6 to get our velocity in meters per second. So let's say our velocity in meters per second now works out to 12.5 meters per second. That's a little bit messy. Okay, let's plug these numbers in. Mass is equal to 2 times kinetic energy in joules. So it's 120 kilojoules, which works out to 120,000 joules, divided by our velocity squared. So 12.5 meters per second. I'll square that. And we get a mass value then of, 1,536 kilos. It's a fairly hefty object. I'll put units on it in a sec here. This is kilograms. Okay, that is part 1 of example 1. I think we can just jump straight into part 2 here. We have lots of space. B. Now B's saying, if this object then loses 70 kilojoules of kinetic energy, determine its final speed. So kinetic energy is based off of how quickly an object is moving. So if we're taking some of its energy away, it means that we're slowing it down, basically is what it's saying. So let us solve for that. Let's say, how do we want to go about this? Let's rearrange our formula first. And if we start with EK, magenta, EK is equal to 1/2 mass velocity squared, and we're now looking for its final velocity. Rearrange this so its velocity is equal to square root of 2 times kinetic energy over mass. And let's put our numbers in. Velocity is equal to square root of 2 times, and I'm going to do this 120,000 joules, and we're subtracting 70,000 joules divide this whole thing by the mass of the object, which we solved for in part 1. So divided by 1536 kilos. We should get a velocity of 8.07 meters per second. That's really all there is to it. Pretty straightforward formula.